Good morning, everybody. I think we will start class.
Good morning, sir.
Okay, we are in second unit. So far, we covered up to cleansing compounds. We have seen oil and fats. Then we are referring about cleaning compounds. Today we will go for soap manufacturing. So now we will go for soap manufacturing. Okay, so we already know what is soap. Nothing but a alkali salt of fatty acid is nothing but a soap. So alkali salt of fatty acid is nothing but a soap. So there are two processes to manufacture soap. So first one among those is batch saponification process. In these two types are there. One is acid hydrolysis of glyceride followed by alkali addition, which is known as a Twitchell process. First, the whatever the glyceride components, fat or oil components are there. Fat is composed of triglyceride. So triglyceride is composed of triglyceride is nothing but an ester of three fatty acids and one glycerin molecule. Is nothing but a triglyceride. So fat or oil is composed of triglycerides, and triglycerides itself is a ester of three fatty acids and one glyceride molecules. So overall the glycerides is whether it may be triglyceride, diglyceride, or monoglyceride. Any glyceride can be referred universally as a glycerides. So here we are referring only to the glycerides. So acid hydrolysis. Acid will acts as a catalyst in just splitting these glyceride molecules. Then the formed fatty acids will just undergo a reaction with alkali. So this process is called a Twitchell process, which is a batch process. Then other process is the direct saponification. Without any conversion to fatty acids, we can directly add the alkali to it and saponify alkali to the fats or oils. Then we can directly saponify it into soap. So this is these two are the batch processes. Earlier days, in the good old days, they many members are used to synthesis the used to manufacture the soap using this batch process only. Okay, in the batch process, in the batch process, especially in the direct saponification process, they cannot separate the glyceride molecule outside of the soap. So including glycerin, including glycerin and alkali, everything will be available in the soap. So this is usually practiced in old days. Okay, now the continuous process of that. The second triglyceride molecules will be hydrolyzed using a water. Then it will be split into three fatty acid molecules and one respective glycerin molecule, because triglyceride is composed of a three fatty acids and one glycerin molecule. So in the hydrolysis step, whatever the triglyceride is there, or a monoglyceride or diglyceride is there, they are stripped of their fatty acid moieties. Okay, they are stripped of their fatty acids moieties. Whatever the fatty acid are found or reacted with the alkali, like NaOH or KOH, then that is known as a saponification reaction. The first reaction in the continuous process is the hydrolysis, in which fat will be split. Fat will be split, meaning the fatty acids will just whatever the fatty acids are there will be separated out from the ester form of triglyceride. So after separating the fatty acids, whatever the fatty acids we obtain will be reacted with the alkali, and that alkali and fatty acids will react. That reaction is called a saponification reaction. So this process is very important in the continuous hydrolysis process. Okay, then okay, yeah, there are many advantages of this continuous hydrolysis and saponification process compared to the batch saponification process. Among those are flexibility in control of product distribution. Okay, there are many flexibilities in operation and control of those processes, unit processes in the soap manufacturing when we are using the continuous process. And other one is the higher glycerin yield. Okay, glycerin yield will be very higher because we are using the continuous process. Glycerin yield will be very higher. Very, glycerin recovery will be very high. It is usually greater than 80%. Then the next advantage is less off color, because in this process you can see in the direct saponification process there will be no step for the separation of glycerin. So glycerin is somewhat a coloring compound. It will initially present as a yellow glycerin. So whatever the color will be there will be uh, there will be color in the direct saponification process. Whereas in continuous hydrolysis process, there is will less color because we are already separating glycerin in this one. So, so in the hydrolysis step, it is the major advantage because it will not have any color compounds inside it. Then next advantage is the require less space and manpower. Obviously, the batch process for loading and unloading of the reactant, we have to invest more on a manpower and more for a space also. Whereas in the continuous process, there is no criteria for loading and unloading. Only one simple loading will be there. The unloading will automatic. Automatically, it will be a continuously a loading unloading will take place. No need of additional manpower in order to load and unload, and then there will be um, no excess time in loading and unloading will be there. So in the continuous process is the advantage of requiring a less space and requiring a less manpower also. Okay, in the hydrolysis process, continuous hydrolysis and saponification process, the raw materials required are the glyceride sources. Okay, glyceride sources can be any type, like oils or fats. Okay, like for example, in the fat range, refined tallow we can use, and recovered and refined greases we can use in the non-edible source. As the edible sources like coconut oil, palm oils can also be used, or we can directly obtain the palm fatty acid distillates or coconut triglyceride distillates. Everything we can use, which will come as, comes under the category of fatty acid distillates. Okay, fatty acid distillates are nothing but individual fatty acids. When we obtain those from any type of operation, from these oils we can obtain the individual fatty acids. That are nothing but a fatty acid distillates. Okay, these are some of the glyceride sources we have to use. Okay, then alkali we have to use in order to carry out a saponification reaction. So alkalis like NaOH or KOH are used. When we use KOH, we call it as a soap. The particular soap we are manufactured when KOH is used is called a soft soap. Okay, which are used in the shaving creams, etc. Whereas when we manufacture our soap using the NaOH in our saponification process, it is called a hard soap, which we use in our daily day-to-day life. Okay, then next one is builders we can add like rosins. Okay, some of the builders like rosins we can add. Otherwise, the perfumes we can add when we want some fragrance inside our soap. We can add some perfumes, other additives we can add. Okay, depends on the particular type of manufacturing. But these are two mainly required um, raw materials for manufacturing of any type of soap. Then the first reaction among those is fat splitting reaction, or we can simply call it as hydrolysis reaction. In this hydrolysis reaction, the catalyst used is the zinc oxide catalyst. Usually for the industrial scale, zinc oxide catalyst is used. Okay, these two reactions, the first one is a fat splitting reaction. Whatever the triglyceride molecules are there, these are splitted into three individual fatty acids, then one glycerol molecules, because triglyceride is nothing but a ester of glycerol and three fatty acids. Okay, this is somewhat same thing. Initially, the glyceride, whatever the triglyceride is there, is just split into two fractions. One is the fatty acid, free fatty acids or fatty acids we can call, and other one is one molecule of glycerin or glycerol. Glycerin or glycerol same. Glycerides we refer to triglyceride, monoglyceride, diglyceride. Whereas glycerin or glycerol is same both. Then whatever the fatty acids we obtain in the fat splitting step or the hydrolysis step is used here to react with the alkali. This is known as a saponification reaction. Then this alkali metal will attack nucleophilically to this free fatty acid or a fatty acid. Then it form a alkali metal of alkali salt of fatty acid, nothing but a soap with the liberation of one molecule of water. So these are the reactions. We can just see the flow sheet. First, the fat plus catalyst, or we can say oil plus catalyst, or we can say glyceride plus catalyst. Simply, we can say glyceride plus catalyst will be passed counter current to the steam, high pressure and high temperature steam. The temperature and high temperature of this hydrolyzer. Okay, this is nothing but hydrolysis step. So, in which glycerides plus catalyst. Okay, glyceride plus catalyst is ZNO. Glyceride sources may be oil, fat, or any farm fatty acid distillate. Anything will be combined and passed counter current to the high pressure and high temperature steam in a hydrolyzer. So the temperature of this hydrolyzer will be 230 to 250 degrees centigrade, and pressure will be in between 40 to 45 atmospheres. Then in the hydrolyzer, whatever the reaction given in A will takes place. The fatty acids, whatever the triglycerides will be there, will be split into glycerin, one molecule of glycerin, and three molecules of fatty acids. Those fatty acids will be separated from the top of the hydrolyzer, and the glycerin formed will be separated from the bottom of the hydrolyzer. Whatever the fatty acids will be formed is nothing but a crude fatty acids. These crude fatty acids are passed through the flash tank in order to separate the excess of steam used in the hydrolysis. After separating this excess of steam from these fatty acids, crude fatty acids, these crude fatty acids will be passed through the high vacuum state. Okay, these crude fatty acids will be uh, passed through this high vacuum stream in order to separate any of the waste products which are present, like excess alkali or excess metal will be there, metal salts will be there, will be separated out here. And whatever the fatty acids will be obtained will be sent to a holding tank, nothing but a storage tank. Okay, from here we can commercialize our fatty acid product for different units, for different product units. Like biodiesel can be manufactured using this fatty acid product. Okay, whereas various biofuels can also be manufactured using this fatty process to manufacture a soap, in which the whatever the fatty acids here are reacted with the alkali like NaOH or KOH in a high speed mixer. Okay, here the mixing of NaOH and NaOH, like alkali, like those. Then this composition of alkali and free fatty acids, whatever are mixed at high speed in a mixer, will be sent to a slow speed blender, in which the saponification reaction will be carried out. The saponification reaction as given in reaction B is carried out, in which the one fatty acid molecule will react with a alkali. Like A, you can see this is A. A is nothing but Na or K. When we are using sodium hydroxide, this A refers to as Na. When we are using potassium hydroxide, this here referred to as K, potassium. So this potassium oxide or the sodium hydroxide will nucleophilically attack this fatty acid and give a alkali salt, nothing but a soap. Then this reaction will take place inside the blender, slow speed blender. Then the formed soap will be sent to the different processing units. If you want a uh, bar type of soap, okay, like we are used in our household purposes. Then we have to pass this soap composition through some heated lines or some molds. We have to keep that particular composition of soap in some molds so that it will be obtained as some bars. Otherwise, when we want our soap as a powder, we have to send this soap composition to the spray dryer. Then from there, the spray dryer, the powder will be obtained. Soap powder will be obtained. Otherwise, when we want some soap as a chips, okay, then we can send this to the chipping unit. A small chips can be produced. So this is the overall saponification process. Up to here is the fat splitting process. Here, from here to here is the saponification process. And this bottom flow sheet is nothing but a glycerin production process. Okay, glycerin production process. Next, we will see what is the glycerin production process. So we know that what is glycerin. Glycerin is nothing but a natural moisturizer or natural lubricating agent. So we are using in our cosmetics, in our pharmaceuticals. Many uses are there in moisturizing agents. Glycerin is very much helpful. Okay, glycerin can be obtained in two type of ways. One is the natural glycerin we can obtain here in the soap manufacturing, or the fat splitting reaction. During the fat splitting, the side product obtained is called a glycerin. Okay, this is called a natural glycerin. So other type of glycerin is there, which is a synthetic glycerin, which can be obtained from polypropylene, which is a petrochemical fraction, which is a petrochemical compound. From this petrochemical compound, we can obtain the synthetic glycerin, whereas natural glycerin can be obtained using the oils or fats, using the triglycerides or fat splitting process. We can obtain the natural glycerin. In order to obtain this synthetic glycerin from the polypropylene, there are two routes. Glycerin. We all know this glycerin is a natural moisturizing agent, natural what lubricating agent. This is so this will found many applications for the glycerin. The first one among is alkyl resin and plastics synthesis. In the manufacture of plastics, these glycerins are very much useful. And then next one is tobacco humidification. For the humidification of tobacco or keeping it moisturized, the tobacco in the tobacco humidification, the glycerin is very much used. The next use is the cellophane plasticizer. We know that cellophane. What is cellophane? Nothing but a thin transparent sheet. In the earlier days, school days, we used to have a transparent sheets around our notebooks. Okay, when we are binding. So that is nothing but a cellophane. During the synthesis of that cellophane, we use this glycerin as a plasticizer. Then next one is explosives. In the explosives also, glycerin will use, like we can say nitroglycerin, trinitroglycerin. Okay, these are all the explosives where the glycerin will found the applications. Like next application is the food and pharmaceutical industry. Okay, United States Pharmacopoeia, usually known as USP, United States Pharmacopoeia, which is the organization which is present in United States, which is responsible for setting the standards for the food grade and pharmaceutical grade glycerin compounds. Okay, this is the organization which is responsible for setting the food grade and pharmaceutical glycerin composition or the glycerin purity. Okay, so these are the uses for glycerin. So naturally, the glycerin can be obtained from the triglyceride composition or during the fat splitting. So this is the fat splitting. Here the after the fat splitting, the co-product or the side product obtained is called a glycerin. So here the 15 to 20% glycerin will be there. The rest will be the water. So the dilute glycerin which is present in water is known as a sweet water. Usually this is known as 15 to 20 percentage glycerin in water is known as a dilute glycerin. This dilute glycerin is referred to as a sweet water. Then this sweet water will be stripped of their metal salt or some coloring compounds by passing it through the anion cation exchange resin is known as a ion exchanger. This sweet glycerins or the sweet water will be anion and cation, successive anion and cation exchange resins will be there to separate, to strip off this glycerin, to strip off whatever the coloring components and whatever the metal oxides are there, metal salts are there, will be stripped off from this sweet water using the anion exchanger. Then the effluent will be passed through the triple effect evaporator. Whatever the composition left after separating the coloring compounds and metal salts, then the composition will be just in order to concentrate the glycerin and evaporate the water and concentrate the amount of glycerin in that one. Then it will be vacuum distilled using the steam in order to get a 99% yellow glycerin. This is a holding tank, nothing but a storage tank. Okay, after passing through the triple effect evaporator and a vacuum distillation using the steam, the 99% yellow glycerin will be obtained. If you want a 99% white glycerin, then we have to separate this coloring compound. Yellow glycerin needs to be converted to white glycerin. So in order to do so, we have to add an adsorbent called activated carbon. The adsorbent activated carbon is mixed with 99% yellow glycerin in this blender. The coloring component is there will be transferred by adsorption to the activated carbon. Then the left out glycerin will be called as 99% white glycerin. Okay, the yield will be around 30 to 50 kg, 30 to 35 kg per every ton of soap. For example, if we obtain 100 kg of soap, in that one we can obtain 30 to 35 kg of soap. So yield will be 30 to 35 kg per every ton of soap. So this is the overall soap manufacturing and glycerin purification process. You can see this one. Then is there any doubt in this one, or shall I proceed? Anybody please respond if you have any doubt. Hello, Pavani, am I
Sir,
audible?
explain once again, sir.
Once, yeah. See, soap formation or a soap manufacture. Soap is nothing but a uh, alkali metal of fat, and this is fatty acid. So alkali metal of fatty acid is nothing but a alkali salt or alkali metal of fatty acid is nothing but a soap. So in order to manufacture the soap, there are two types of production processes. One is the batch saponification process. So in the batch saponification process, what among those batch saponification process, there are further two processes. One is acid hydrolysis, in which acid will act as a catalyst in order to split the glycerides to respective fatty acids and glycerin molecules, because triglyceride is nothing but a three which is the ester of three fatty acids and one glyceride molecule. Okay, earlier we have defined the triglyceride here. We have defined the triglyceride. Here you can see we have defined the triglyceride here. Triglyceride is nothing but a ester of one glycerin molecule together with a three fatty acid molecule. These are three fatty acid molecule, and this is a glyceride backbone. Okay, to one glyceride molecule, the three fatty acids are attached. It is nothing but a ester of which is nothing but a ester of three fatty acids with one glyceride molecule. Is known as a triglyceride. So oil is majorly composed of these triglycerides. So whatever the alkali metal is there, it will be attached to this fatty acid, is known as a soap. To manufacture the soap, so there are two processes. One is the saponification, batch saponification process. In the batch saponification process, further there are two processes. One is acid hydrolysis. In this, acid will act as a catalyst in hydrolysis of these triglycerides to individual fatty acids and glycerin molecule. Then the obtained fatty acids will undergo a reaction with alkali like NaOH or KOH, and this is known as a saponification. So acid hydrolysis of glyceride followed by alkali addition is known as a Twitchell process. This is a batch process. Then in the batch process itself, there are other process which is known as a direct saponification using strong caustic like NaOH or KOH. Okay, without any separation of the glyceryl. so that it will be saponified and the final soap can be obtained without any separation of glycerin. This process used to be they use to manufacture soap. Many people are using this direct saponification process, in which there is no separation of glycerin. Together with soap, glycerin also will be there in those types of soaps. So the next process is the continuous hydrolysis process and continuous hydrolysis and saponification process. In this, there is a glycerin separation process is there. So the advantage of continuous separation process over the batch saponification process is there will be a flexibility in control of product distribution, because we can in the continuous process we can separate the process automatically. So there will be some flexibility in adopting the So the first advantage is flexibility in control of product distribution. Then the second advantage is higher glycerin yield. Since we are separating glycerin in the continuous process, so glycerin yield can be will be very high, so that we can use this glycerin for some other purposes like moisturizers, cosmetic purposes, like in some explosive synthesis purposes, etc. We can use. So higher product yield can be obtained, higher glycerin yield can be obtained in the continuous process. Then less off color, because glycerin is already separating. So this glycerin is during the hydrolysis. This glycerin is mainly um, formed in the hydrolysis, which will add some color to the soap. So finally, manufactured soap will be less color. So in the continuous process, this will be very advantageous. So color, whatever the color we want to use, we can use, rather than the many off colors which are produced during the hydrolysis. So next advantage is it is require very less space and manpower. Okay, in the batch process, what we know for unloading and loading for every batch, we need to have some extra manpower. We need to give some extra load. We need to give some extra space to it. Okay, whereas in continuous process, once we load, everything will be continuous and comes outside. The product will comes outside automatically, and automatically the loading will happen. Okay, we need less manpower in that one, and together with the less space also. So these are the advantages of this continuous process over this batch saponification process or the structural process. So the manufacture of soap, the raw materials required are the glyceride sources. So glyceride sources are nothing but a oil or fat sources, which are nothing but triglyceride sources, or triglyceride or diglycerides, or monoglyceride sources. So whatever the glycerides are there will be present in some oil or fat composition. So we will supply this as a raw material, like refined tallow we can supply. Otherwise we can use recovered or refined grease we can use as a triglyceride source, or we can use coconut and palm oil as a triglyceride source, or we can use palm fatty acid distillate directly for the saponification process. So these are the sources. These 4 to 5 types are the sources as the triglyceride molecules. Then along with this triglyceride, we need to supply for the saponification alkali. We need to supply like NaOH or KOH. We have to supply. These are the two raw materials which are major ingredients of any soap. Whereas these builders, for obtaining some excessive uh, like cutting efficiency, excessive like perfumes we can add for the fragrance, etc., will all comes in the builders or additives. Okay, these are other types of raw materials we can add. These are optional, whereas these two types of raw materials are the must and should. They are the main ingredients in the manufacture of soap. So these two are the reactions. The first one among those is the fat splitting reaction. So fat splitting, in the fat splitting, what will happen, I will show in the mechanism. I will have a mechanism here. Okay. Here you can see in the hydrolysis of fat splitting mechanism. This is a fat splitting mechanism. Triglyceride or the oil molecule or the fatty acid. Okay, yeah, we need to break this triglyceride molecule into three fatty acids, three individual fatty acids or nothing but free fatty acids, and one glycerine backbone. We need to break this one. This is called a hydrolysis. Okay, breaking of this triglycerides into individual fatty acids and glycerine is known as hydrolysis or a fat splitting. So this is a triglyceride molecule which is there in the oil or fat, which we are supplying as a raw material. Then it will be hydrolyzed. This, whatever the hydrogen is there, whatever the water is there, It will attack on the nucleophilicity, what we'll call, it will perform a nucleophilic attack on this fatty acid molecule here. It will attack here the nucleus of free fatty acid. This H is there, this proton will attach to this one, then it will form a diglyceride. Okay, along this liberation, this one fatty acid will be liberated out. This you can see R3C double bond O, this one, and H is a proton from the hydrogen will be attached to this one, and OH will go to this one. So this is called diglyceride molecule. So this diglyceride molecule will further undergo a hydrolysis step. Same nuclear, this water molecule will nucleophilically attack this fatty acid molecule, second fatty acid molecule in the diglyceride molecule. Then this will be separated out. This fatty acid will be separated out as this one, and along with the liberation of one molecule of monoglyceride. So this is only monoglyceride because it is composed of only one fatty acid and one glycerol backbone. Okay, because here see it is called diglyceride because it is of two fatty acids, composed of two fatty acids along with one glycerol backbone. This is called triglyceride because it is composed of three fatty acids along with one glycerol backbone. So this monoglyceride will further undergo a hydrolysis. See here, this monoglyceride will further undergo a hydrolysis. Hydrolysis means nothing but a nucleophilic attack on the fatty acid moiety. In this fatty acid moiety, it will the water molecule will attack it nucleophilically. Then a free fatty acid or a fatty acid will be separated out. Here in the final step in the monoglyceride to fatty acid separation, the formed molecule will be glycerin or glycerol we can call. So this is the overall mechanism for the fat splitting or the hydrolysis reaction. So this reaction will take place in the hydrolyzer, in this hydrolyzer step. So here the starting of this flow sheet is here. Fat plus catalyst. Fat is composed of, fat or oil is composed of triglycerides. So first reactant will be a triglyceride, or glyceride plus catalyst will react with each other and it will pass counter current to the steam. Steam is nothing but hot water at high temperature and high pressure. The temperature and pressure will be, the temperature will be 230 to 250 degrees centigrade and pressure will be 40 to 45 atmos in the hydrolyzer. Then this fat plus catalyst will be, catalyst already I said you ZNO, zinc oxide catalyst will be added together with this fat in counter current fashion to this steam at high pressure and high temperature. Then fat will be split into three fatty acids and one glycerol molecule. Then these free fatty acids, the three fatty acids will be separated from the top product of the, as a top product of the hydrolyzer, and one glycerin molecule is there will be separated as the bottom product of this hydrolyzer. Whatever the top product is there, fatty acids will be sent to the flash tank in order to separate the excess steam. Whatever the excess steam used in the hydrolyzer will be separated in the flash tank. Then the crude fatty acids, these are called crude fatty acids, will be sent to a high vacuum steam or nothing but a steam distillation. Okay, steam distillation. Then the whatever the off products will be there will be separated out as a waste, and the pure fatty acids will be sent to the holding tank or a storage tank. If you want these fatty acids for other purposes like biodiesel or some biofuel manufacturing units, these fatty acids we can send or sold to the other manufacturing units like biodiesel plants or some biofuel manufacturing plant. We can sold here, we can commercialize these fatty acids. Otherwise these fatty acids can be used for the saponification process. To carry out the saponification process, these fatty acids will be reacted with a NaOH or NaOH or KOH, whatever the alkali is there, whatever the alkali we want to use will be used here. It will be mixed, alkali plus fatty acids will be mixed at high speed in a mixer. Then it will be sent to a blender in which the alkali and fatty acids will be blended at low speed. The saponification reaction will take place. Saponification reaction as given in reaction B will take place in which fatty acid, this one here the three fatty acids are there. In this one fatty acid molecule, for example one fatty acid molecule will react with one alkali molecule to give a soap. Okay, salt of alkali fatty acid, alkali salt of fatty acid, nothing but soap. It will form a soap and with the liberation of one molecule of water. So that reaction will take place in the low speed blender. In this blender, the final product will be soap. Whatever the soap is there, the whatever the end product we want. Depending on that end product, we can obtain the soap in any form. Like if you want a bar form, whatever the bars we are using in our bathing will be manufactured by sending this soap composition, by passing that soap composition to some heated lines, or to putting that soap composition in certain molds. Okay, certain molds, then that will be obtained as a bar soap. And if you want that soap as a powder, we can send this soap composition on chips. If you want our soap in small chips, then we can send it to some chipping rolls, so that we can obtain some chips, small chips. Okay, so this is the soap manufacturing. This is the saponification reaction. Here this is the hydrolysis reaction of this flow sheet. Then whatever the byproduct or the side product is there, glycerin, will be obtained to the bottom of the hydrolyzer. So this is called a natural glycerin. So this is a natural glycerin manufacturing flow sheet. This one, bottom one. So this is 15 to 20% around. When the hydrolysis step is carried out, 15 to 20% of glycerin can be obtained. This is called a natural glycerin. So 15 to 20% glycerin in water is called a sweet water. Okay, because its taste is in sweet. So this is called sweet water. Whatever the sweet water is there will be passed through the ion exchanger, in which anion and cation exchanges will be there. Cation exchange resins will be there in order to remove the metal oxide. Okay, here the catalyst is there, ZNO. Some metal will be there here. So some color will be there. So to separate the color and metals from this one, so it will be passed this sweet water. Nothing but a 15 to 20% glycerin will be passed through the ion exchanger. So the after passing through this ion exchanger, the solution will be passed through the triple effect evaporator, and simultaneously using a vacuum distillation unit, whatever the water will be there will be separated out. This 15 to 20% glycerin will be obtained as a 99% composition of yellow glycerin. So some coloring compounds will be there. So this is called yellow glycerin. This yellow glycerin will be sent to the activated carbon absorber. In this, it will be mixed. This yellow glycerin will be mixed with the activated carbon adsorbent, so that we can obtain a 99% white glycerin. So this activated carbon, whatever adsorbed here, will be separated out in a filtration unit. So we will obtain 99% glycerin. So this is a natural glycerin manufacturing process. So in this flow sheet, there are three steps. The first one is this one, tank hydrolyzer, high vacuum still, and holding tank is called a fat splitting, or nothing but a hydrolysis step. This is the saponification step. Mixer, blender, and this soap manufacturing is called a saponification process to synthesize a soap. And this bottom reaction, bottom flow sheet, is called a whatever ion exchanger, triple effect evaporator, vacuum still, holding tank, activated carbon adsorber, filter is called a, this whole flow sheet is called a already seen. So we already seen this is a natural glycerin manufacturing process. So for the glycerin manufacturing, there are two types of process. One is the natural glycerin manufacturing process, which we already seen in the soap manufacturing. The next one is the synthetic glycerin. So synthetic glycerin can be manufactured using the polypropylene, which is a petrochemical compound, or which is a petrochemical product. Using this petrochemical product polypropylene, we can manufacture a synthetic glycerin through two routes. One is allyl chloride route, and next one is acrolein chloride route. So uses why this glycerin needs to be separated from the soap manufacturing, because when we are separating the glycerin, we can use that glycerin to some other purposes, like this one for the manufacturing, the manufacturing of alkyl resin and plastics. This glycerin can be used. Okay, in the humidification of tobacco, this glycerin can be used. In the manufacture of cellophanes, glycerin can be used as a plasticizer. In the manufacture of nitroglycerin, trinitroglycerin as explosives. We can use glycerin in the manufacture of foods, food grade products or some pharmaceutical products. The glycerin can be used as some ingredients. So glycerin will have this type of many uses. So United States Pharmacopoeia, which is the standard organization to set a standards for the glycerin composition or the glycerin purity in order to use them in a food and pharmaceutical industries. So these are all the uses, so that we have to separate the glycerin from our triglyceride molecule, so that we can use that glycerin in this type of manufacturing units. So I hope you understood that soap and glycerin, natural glycerin manufacturing, this flow sheet. And next one is synthetic glycerin. Okay, I already said you there are two synthetic glycerin manufacturing processes. One the raw material will be polypropylene, propylene for this type of synthesis. There are two routes for synthesis of this synthetic glycerin. One is allyl chloride route, and next one is acrolein route. So first one we will see the synthetic glycerin from polypropylene via allyl chloride route. So here only reactions are given in your textbook, no flow sheet is there. Just you need to practice this reaction. This is first one, the propylene will be there, which is a petrochemical fraction or a petrochemical product. This propylene will be chlorinated using the chlorine at a high temperature 400 to 500 degrees centigrade in order to yield a allyl chloride with the liberation of one molecule of uh, hydrochloric hydrochloric acid. So this whatever the allyl chloride is there, which is nothing but a chlorhydrin, we called it as a chlorhydrin, will be reacted with hypochlorous acid. HOCl is called hypochlorous acid. It will be reacted dichlorohydrin will undergo a reaction with important ingredient in the manufacture of epoxy resins. Certain types of resins will be manufactured using these ingredients called. Want a synthetic glycerin, we can use this hypochlorohydrin here as a raw material. This hypochlorohydrin will be reacted with alkali and hydrolyzed to give a glycerin. The yield of this synthetic glycerin will be around 75 to 80%. Okay, once again I am repeating. The polypropylene, which is a petroleum composition, will be reacted or chlorinated using a chlorine at a high temperature 400 to 500 degrees centigrade to yield allyl chloride with a liberation of one molecule of HCl, okay, hydrochloric acid. Then this formed allyl chloride HOCl is called a hypochlorous acid. This reaction will yield a glycerol dichlorohydrin. Then this glycerol dichlorohydrin will react with calcium hydroxide, in which it will give a epichlorohydrin as a product. This epichlorohydrin can be used for various other manufacturings like epoxy resin synthesis, or otherwise we can use this epichlorohydrin for the synthesis of glycerin. So in which epichlorohydrin will be reacted with alkali NaOH. It alkali, then the final product between the final product of reaction between epichlorohydrin and alkali and water is called a synthetic glycerin. The yield of this synthetic glycerin through this allyl chloride process is 70 to 80% yield we can obtain. So then next process is the synthetic glycerin from the polypropylene via a acrolein route. So this is allyl chloride route, this is acrolein route. So the raw material is same, polypropylene, which is a petrochemical compound. We can use this as a raw material for that process also, for this process also. So here propylene will be propanol will oxidized at a temperature of 120 degrees centigrade and a pressure of 2 atmos to give hydrogen peroxide and acetone. Then this propylene, then the propylene will be simultaneously hydrolyzed and oxidized using a copper oxide catalyst at 350 degrees centigrade and 1 to 10 atmos pressure to give a acrolein. So this is called acrolein route. The acrolein, the formed acrolein is there, will be reacted with isopropanol obtained in the first reaction. Then the catalyst for this reaction is magnesium oxide or zinc oxide, and the temperature is 400 degrees centigrade to yield allyl alcohol. Allyl alcohol along with the liberation of one molecule of acetone. Then this allyl alcohol will undergo a reaction with hydrogen peroxide, which is formed in reaction B, and the catalyst for this is tungsten trioxide. This is WO3 is called a tungsten trioxide catalyst. In presence of tungsten trioxide catalyst, the allyl alcohol and hydrogen peroxide to react to give synthetic glycerin. The yield of this synthetic glycerin through this acrolein route is 50 to 60%. I am repeating once again this reaction. Yeah, so propylene will be used as a reaction in this reaction also. So propylene will be hydrolyzed to give isopropanol. Then this isopropanol will be oxidized at high temperature 120 degrees centigrade and 2 atmospheric pressure to give hydrogen peroxide and acetone. Then this propylene will be reacted, and propylene will be hydrolyzed and simultaneously oxidized in presence of copper oxide catalyst at 350 degrees centigrade and 1 to 10 atmospheric pressure to give acrolein. So then this acrolein will be reacted with a isopropanol, which is obtained in reaction A in the presence of magnesium oxide or zinc oxide catalyst at 400 degrees centigrade to give allyl alcohol and one acetone molecule. This allyl alcohol will be reacted with the hydrogen peroxide obtained in the reaction B using the tungsten trioxide catalyst at 60 to 70 degrees centigrade to give synthetic glycerin. Then this synthetic glycerin obtained will have a yield of 50 to 60%. Okay, these are the two routes for the manufacturing of synthetic glycerin, and for manufacturing of natural glycerin, this is the flow sheet. Okay, now it is okay. Any doubt? Can somebody respond, please?
No doubt, sir.
Yeah. Okay. Okay, the last topic of this unit is we will cover that in next class. So the last topic will be the manufacturing of detergent. So far we have seen in this unit is oils and fats, their definitions, and then oil production, how to extract oil from the seeds, and the next one is the soap production, definitions of cleansing components, various forms of soaps, and various types of detergents. Then now we have seen the manufacturing of soap. In that one we have already seen the natural glycerin manufacturing. Then together with the synthetic glycerin manufacturing using propylene we have seen. Then the last topic is the detergent manufacturing. So this unit is very small. You can only roughly we will have one, two, three, yes, 3 to 4 flow sheets. Okay, one is hydrogenation. First one is extraction of oil from the oil seeds, one flow sheet, and next one is the hydrogenation of oil, one flow sheet, and the third one is the manufacturing of soap and natural glycerin, one detergent manufacturing, one flow sheet. Okay, roughly 4 flow sheets are there together for the synthetic glycerin. These two reaction schemes are there. Okay, you have to read this one. These are the two processes. Okay. Uh, Anionic cationic soaps are there in this one. We already seen anionic, cationic, and non-ionic soap. So out of that, the sulfonates are there in the anionic soaps. Popularly, we use that anionic soap for our day-to-day life. So in that one, there are sulfated fatty alcohols. So we will see first one. For this one, there is a flow sheets to manufacture sulfated fatty alcohols. Nothing but a detergents. The next one is alkyl aryl sulfonate. So this is also cationic molecule. To synthesize this, we need a kerosene. The paraffin is obtained from the kerosene as a raw material. This is known as aryl benzene sulfonate. So these two are there. Out of this, only one flow sheet is there. Okay, this PPT is arranged mechanism of that fat splitting or saponification. You can refer this one. Hydrolysis of fatty acid mechanism I have given in the last two sheets of this PPT. So this is the saponification process. In the saponification mechanism, you can see the alkali. This is A is nothing but A or Na or K. So alkali is reacting with water. So here it will form a plus cation and OH minus anion. This A plus will nucleophilically attack this fatty acid molecule and form a alkali salt of fatty acid, nothing but soap, and with the liberation of one molecule of water. So this is the saponification mechanism I have given in the last slide, and this is the hydrolysis or fat splitting mechanism. Okay, if you have any doubt, you can refer to last two of this PPT. Once we complete this detergent manufacturing, I will send you the PPT. You can refer. So my request is to just write down the notes and prepare. I will also give assignment for this unit and as well as first unit also. Yeah, I hope you understood this one. Okay, from the boys side, anybody is having doubt?
No, sir.
Okay, so far you can ask first unit also, second unit also. Anything? Okay, then anything to say? 8 minutes or left around. Okay, what are you planning to do in this 3 days? Something we are getting holidays. 2 days we are getting holidays.
4 days, no, sir.
4 days. Yeah,
Yes,
yeah,
sir.
yeah. Monday is also holiday. Yes, yes. So
Yes, sir.
please, yeah, yeah. What are you doing? What are your plans? Yeah, just talk casually.
We have to write notes, sir. A lot of incomplete.
Okay, really? You're writing.
Records also,
Yes,
sir. Records also, sir.
Record also you're writing, no?
Yes, sir. Heat
Okay.
transfer record.
Wow. Yeah, yeah, yeah. If possible, write CT record also. I'm not
yes,
burdening
sir.
you. Just asking you. I'm not burdening you. Once classes will be started, physical classes, then we can go for that one also. So otherwise, you have to
Project
write
work,
on.
sir. We have to
Yeah,
refer journals and do project work.
yeah, yeah. Journals you have to refer. You have to write that one. So
We
I
have
think
to
you are
prepare
doing.
for IARS exam also, sir.
Okay, yeah. You also have an exam there to that one.
Yes, sir.
IARS.
Yes. Yes, sir.
It's
How
very
was the
simple exam.
paper, sir?
It's very simple exam. Daily what they thought they will
Yes,
ask
sir.
in that only.
Yes, sir.
Yeah, it is very easy exam. Nothing to worry. Only 24 marks we have to score, I guess. Something 40 percentage around.
No, sir. They will give 50 questions. They will tell the pass percentage later.
Yeah, yeah, that's the criteria. But initially they will announce that only 40% is the pass marks. Ours
Okay.
is 60 minutes and 60 questions they have given. For each minute, yeah, sorry. Then only if you score 40%, then only we can get certificate. They don't announce the result immediately. If we obtain a 40%, more than 40%, then only they will give certificate.
Yes, sir.
Yeah, yeah. All the best. When is the exam? What date?
From August 24 to August 28, it seems.
Oh, August 24. Course is completed or it is going?
Completed, sir.
Already completed, but they are taking this much time. August 24.
For
Okay.
this exam, for this course, around 12,000 students registered, it seems, sir.
Oh, okay, okay. For our exam also, around 50,000 something they announced. 50,000 something
Yes.
participations they have received. Out of that, somebody around 30,000 or 40,000 they are shortlisted. And we completed on 1st July, we completed our course. And they conducted our exam on 7th to 10th. Okay, they have kept only 3 days for the exam. It is
Yes.
too far. You will forget all the things, what they have taught, everything in between this time. Up to 24 means it's a huge gap.
Yes, sir.
Yeah. What is the title of the course?
Geoinformatics applications, sir.
Geoinformatics. Okay. Yeah, we are also done the same thing.
Yes, sir. You did the geoinformatics. We did the applications of that.
Yeah, including this one also applications are there. GIS and
Mm-hmm.
GIS application something is there. I don't know exactly. That's not our core subject. Just accidentally I participated in that one. It was nice. We have known many things regarding heat transfer. We will know many things. How the heat is being transferred through radiation. It will be a huge benefit for your heat transfer course, I guess. How the heat is being transferred through radiation, through space and everything. It's a nice course.
Yes, sir.
Number 11. Yeah. Number 11. Are you there? Okay, I'm not asking to raise your hand. I'm asking to respond. Okay, no problem. Okay, I hope you enjoy the holidays. Thank you. Bye. If you have any doubt, just contact me anytime. Okay, bye.